Hi guys, welcome to your lesson on the periodic table. So we started this cycle off with a detailed study on the atom. So we learned about protons, neutrons, electrons, and we learned about how you can look at the periodic table and look at the atomic number, and that tells you how many protons that an atom has. You can look at the atomic mass, which is the protons plus the neutrons. And because we know that every single element on the periodic table is neutral, has a neutral charge, we know that that must mean the number of protons and the number of electrons is equal. Because when you have a plus and a minus, it cancels each other out. And that means neutral charge. So if we know the number of protons, let's say it's 5, then we also know that the number of electrons is 5. Okay, so now we're going to get into the origin of the periodic table and how it's arranged. So Mendeleev he's the one who came up with the first arrangement of the periodic table, and he arranged it by atomic mass. He found that as he arranged elements, that similar properties repeated themselves. Okay, this is his Mendeleev's version of the periodic table. We know that it looks much, much different today, but this is what it started with. And again, if you look, it's all arranged by atomic mass, starting from smallest and going to biggest. There were gaps in his table which led other scientists to discover new elements. Moseley devised the current periodic table, which is based on atomic number. So remember, atomic number is like an atom's thumbprint. No two atoms have the same atomic number. So that means no two atoms have the same number of protons either. So the current periodic table, the word periodic actually means repeating, so a repeating pattern. The periodic table groups similar elements together. I'd like to use the grocery store as an example. So we have a produce section, a meat section, a chip aisle, a laundry detergent aisle. There's certain products that are similar that are grouped together, and the periodic table is the same way. So grouping it makes it easier to predict the properties of an element. You wouldn't group chips with laundry detergent in the grocery store. So the periods in the periodic table are the horizontal rows of elements, and there are 7. Just as the number of protons changes as you move from left to right across the periodic table, so does the number of electrons. So remember that we have the equal number of protons as electrons. So as we move from 1 to 2 to 3 to 4 to 5 protons, we're also moving from 1 to 2 to 3 to 4 to 5 electrons because they're equal. So remember that sentences, when we write a sentence, we write them in a row. We write it horizontal with a period at the end. That's how you can remember periods go across. Periods go across. So the red goes across, the orange goes across, the yellow, the green, the light blue, the dark blue, the pink. Those are periods that go across. Groups. So my trick for remembering groups is the way that the word is spelled, G-R-O-U-P. So groups go up and down, and the word up is in the word group. Groups are vertical columns of elements on the periodic table. There's 18 groups. Remember that group is spelled G-R-O-U-P. So groups go up and groups go up and down. Elements in the same group have the same number of valence electrons. So remember, valence electrons are the electrons in the outermost shell. And you can tell how many there are by looking at the group number, which is the little gray box up at the top. And remember, we don't look at the transition metals. We go from 1 to 2, and then we don't use 3 through 12 if you're looking at the periodic table, but we start back up at 13. So we do 1, 2, and then go to 13 through 18. And 13, we just look at the second number. So we look at the number 3 that tells us that in group 13, there are 3 valence electrons. How many are in group 18? Yep, 8. And how many does each atom want to be happy and full? 8. Every atom's goal is to have 8 valence electrons. That's what will make happy. Okay, so valence electrons are responsible for atomic bonding. So when two atoms bond, when they get together, if you look in the picture, there's an oxygen bonding with 2 hydrogens. That's what makes water. So remember, valence electrons is equal to the last digit of the group number. So if you look at this atom on the bottom right, how many valence electrons are in this atom? Yep, 6. So you just look at the outside dots, the outside electrons, and count them. And there's 6. So what group would it be in? It would be in group 16. And if you're looking at the periodic table here, the colorful one with no letters or numbers, it would be in the light blue column, the third one from the right. So, more about groups and valence electrons. Valence electrons determine an element's properties. So all elements in the same group have similar properties. So this is like the aisle of the grocery store. Every element that's in the same group, the same up and down group, has similar properties. So you can think of these like the grocery store. Well, what makes them different then? If you look, they have different atomic numbers and they have different masses. Okay, remember groups go up and down. So families are the same as groups, and think of each element as a member of a family that's related to other elements nearby. So if they're in the same group, they're in the same grocery store aisle, they're in the same family. So they might be in the chip family, or they might be in the produce family, but they're all a certain kind of something. So elements are classified as metals, nonmetals, or metalloids. So groups are sometimes called families, and then there's different metals. There's lots of different kinds of metals. There's different nonmetals, and there's different metalloids. Okay, here's the picture showing you the breakdown, and you can obviously see that there's mostly metals on the periodic table, all the green. The metalloids are the stair steps. Those are the purple ones, and the nonmetals are the orange ones. Notice we have hydrogen way over to the left, number 1, which is a nonmetal. It's over to the left because it has 1 proton. So, some physical and chemical properties of metal. So we know metals are shiny, that means luster. They're good conductors, meaning electricity flows through them. They have high density, so they're very dense, they're heavy. They're ductile, which means they can be made into thin wires. They're malleable, which means they can be bent easily and hammered into thin sheets. And most of them are silvery. Chemical properties. Metals corrode, which means they wear away because of chemical reaction with water. And they're very reactive. They bond with other atoms. Here's some examples of some metals that you might be familiar with. So, the different metals in the grocery store. Alkali metals. These are very reactive. These are in group 1 of the periodic table. Alkali earth metals. They form compounds that are found in our bodies. Calcium and magnesium compounds. And then we have transition metals. These properties gradually change from being more similar to group 2 to being more like group 13. So these are the ones that go from 3 through 12 that are in that lower part of the periodic table. Okay, so look at that lower part, 3 through 12. Those are all transition metals. The most reactive metals are in group 1 on the very, very left side of the periodic table. And does anyone remember which other group they bond with? So remember, if they want to have 8 valence electrons and they have 1, how many do they need to make 8? Yep, they need 7, so they're going to bond with group 17. So nonmetals. Nonmetals aren't shiny. They don't have luster. They don't conduct electricity. They're brittle. They break easily. They're not ductile. You cannot bend them easily. They're not very dense, and many are made of gases. They can be solids and liquids, but most are made of gases. Chemical properties, they are highly reactive. All except for hydrogen are on the right-hand side of the periodic table. Remember, these are the orange ones. All right, metalloids are semiconductors. The properties, they're shiny or dull. They're conductors, but not as good as metals, and they're ductile and malleable. There are only 6 of these total, 6 metals. Excuse me. All right, the lanthanides and the actinides. These are rare earth elements, and if you look down at the picture, these are the ones that are at the very bottom of the periodic table, and they're the same color as the two that are up there. Most of the actinides have been synthesized by nuclear scientists, except for uranium and thorium, and these were all not discovered until much later, which is why they are down below in the periodic table. Okay, there you go, and they are metals. They're down below because they were explored or discovered later. And that is it for our lesson on the periodic table. Please make sure that you write down any questions you have so that you can get a mini lesson in class. Thanks. Have a great day.